Hello students, today we are discussing the topic substitution reaction. Now in any organic reaction there is a substrate on which the reagent reacts to form a product. Now in case of a substitution reaction the reagent is called a substituent. Now a substituent may be a nucleophile or an electrophile. Now a phile in English phile means love or attraction. An electrophile means a substituent which has a tendency or which has an attraction or love towards. In case of a nucleophile, it has an attraction towards a nucleus or a positive center, and in case of an electrophile, it has an attraction or love towards a negative center or electrons. Now, in case of a substitution reaction, the substituent actually substitute a group from a compound to form another compound. Now, as in case of hydrolysis of an alkyl halide, which minus actually substitutes Cl to form and Cl is removed from the alkyl halide, alkyl chloride as Cl minus. Today we are going to discuss nucleophilic substitution reaction, that is where the substituent is an alkyl. Now this reaction passes through two different mechanisms, though the product will be same. That is, in hydrolysis of an alkyl halide, we use KOH, potassium hydroxide, in aqueous medium. Then, if we treat an alkyl halide with aqueous KOH, an alcohol is formed. Now the reaction may follow either SN1 reaction mechanism or SN2 reaction mechanism. Now, in case of SN1 reaction, in the rate determining step, a carbocation is formed. Then the nucleophile, that is OH minus, comes and bonded to the carbocation to form the alcohol. And in case of an SN2 reaction, the reaction passes through a transition state where no bond is fully formed and no bond is fully broken. That is, the process is concerted when the entering group comes to attack to the carbon where the leaving group is bonded. The leaving group is still attached in the transition state. So the transition state, 5 bonds are there around the carbon, so it is in a stress condition. So greater the crowdedness in the transition state, lesser will be the stability of the transition state. That is why in presence of a bulky methyl group around the carbon, the transition state becomes crowded and less stable. Hence, greater the substituent or greater the alkyl substituent present in the molecule, lesser will be the rate of SN2 reaction. And in case of an SN1 reaction, since a carbocation is formed, presence of more number of alkyl substituent will stabilize the carbocation through their plus inductive effect or resonance effect. That is why more substituted alkyl halides follow SN1 reaction mechanism and less substituted alkyl halides follows SN2 reaction mechanism. Secondly, in SN2 reaction, the reaction passes through a transition state where no bond is fully formed and no bond is fully broken. Thus, the process is concerted and the backside attack occurs. That is where the Cl is present. The entering group, that is OH minus, comes from the opposite side. Now, in case of SN1 reaction, since a carbocation is formed, now the OH minus can come from both sides. That is why two enantiomers are formed with the 1:1 ratio and the solution becomes optically inactive. This is called a racemic mixture, and the incident is called a racemization. Though the two enantiomers which are optically active but their presence in 1:1 ratio makes the solution optically inactive. This is called racemization. And in case of SN2 reaction mechanism, since backside attack takes place, the configuration becomes inverted, and this is called inversion of configuration. So in SN2 reaction mechanism, inversion of configuration occurs, where in SN1 reaction racemization occurs.